Following on from some of the early videos, we're trying to seek a function here in such a way that will map on top of this function. And the way we did it was that we demand the first derivative to match up with the first derivative, the second derivative to match up with the second, the third derivative to match up with the third, fourth to match up with the fourth, and so on. We've always demanded that they match up with each other, even with the original function. We've always demanded that they match up with each other. And then we looked at this example here where if you look at this, here you've got x to the power 1, x squared, x to the power 3, x to the power 4, 5, and so on. We could take it up all the way to infinity. So really, we are seeking a function in such a way that it will map on top of this one. And the way we did it was that we demand the first derivative to match up with the first, the second derivative to match up with the second, third to match up with the third, and so on. So you seeking a function where it will map on top of this function, it's really you seeking all these coefficients here. You're seeking this coefficient, you're seeking this coefficient, because if you look at this, x goes up here, x goes up by 1 each time, x to the power of 1, x to the power of 2, 3, 4, 5, and so on. The pattern continues. So you seeking this whole function, it's really you trying to seek these coefficients. You trying to seek these coefficients. So when remember, we are evaluating this at x equals 0. We are evaluating it at x equals 0. We are evaluating it at x equals 0. So for us to seek this function, it really boils down to us trying to seek these coefficients. So at x equals 0, if you put this into the x here, this one would disappear. Put it into the x here, this would disappear. Put it into the x, it would disappear. Put it into the x, it would disappear, and so on. So your first coefficient is really you evaluating f of 0, because you would put 0 into this x here. So the first coefficient is f of 0. So the first coefficient, so remember, you're seeking this whole function. So really you're seeking all these coefficients. Well, the first coefficient is f of 0. And then for the second coefficient, you would demand the first derivative here to match up with the first derivative here. Well, at x equals 0, if you put this into the x here, this would disappear. Put it into the x, this would disappear. Put 0 into the x here, disappear. So for your a1 coefficient, it will be f prime of 0, because if you look at this here, when you demand this to match up with this at x equals 0, this would disappear, this would disappear. So your a1 here, you're seeking this. Remember, you're seeking this whole thing here. So you've got a0 already. Well, a1. Remember, a1 is really f prime of 0, because you're evaluating at x equals 0. So when you put it into here, all these disappear, and it really boils down to a1 equals f prime of 0. So remember, you're seeking this whole function here. We've got this coefficient. Well, this one here is f prime of 0. So this coefficient here is f prime of 0, and then you've got your x here, and then you've got your x here, and then for this coefficient here, we would look at the second derivative. We would demand that this to match up with this. So for the second derivative at x equals 0, put 0 into here, so this will disappear. Put 0 into here, this will disappear. Put 0 into here, this will disappear. So leaving you with this. So for the next coefficient, well, you're seeking a2. Well, a2 would be f double prime evaluated at x equals 0. And then you've got to divide by this 2. So for this coefficient here, it will be f double prime evaluated at 0. It will be f double prime evaluated at 0, and then you've got to divide it by 2. You've got to divide it by 2. So this coefficient here, would be this thing here, and then you've got your x squared, you've got your x squared. And then for the for the next coefficient, a3, you would demand the third derivative here to match up with the third one here. Well, at x equals 0, this will disappear, this will disappear. So you're trying to seek a3. Well, a3 is really you dividing both sides by 3 factorial. So your a3 here is really you finding the third derivative, evaluated at 0, divided by 3 factorial, So your a3 here is really this coefficient. This is your a3 here. And then for the next one, you would look at the you would demand the fourth derivative to match up with this. Well, at x equals 0, you would put this into here. This whole thing here would disappear. So really you're left with this. So your a4 coefficient would be you evaluating the fourth derivative. At x equals 0. So you put 0 into here. So for a4 you would divide both sides by 4 factorial. So for your a4 here, it would be the fourth derivative. Evaluated at 0, divided by 4 factorial. So that would then give you your fourth. That will give you your a4. So this is a4. So a4. This is a4. X to the power 4. X to the power 4, and so on. So when you demand the first derivative to match up with the first, the second to match up with the second, third, whenever you demand this, it will generate this series. It will generate this series. So you can tidy this up. You can tidy this whole thing up all the way to infinity. You can write it in this form. So this is your what's called your Maclaurin series. Okay, so yeah, so just know that the reason why you generate this series is because you've demanded that the first derivative to match up with the first, the second to match up with the second, third, and so on. Even with the original function, you demanded that they all match up, and then when you make that demand, it will generate this this series. Well, you can tidy this up. So this here is your Maclaurin series.